Hey everybody, this is Larry. This is me doing the day 14 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem, word ladder 2. Also, for my usual people, I do an extra problem because nowadays I feel like every problem I've done before, even though I don't always remember it to be fair because my memory's been old. But so yeah, just a little bit more practice. So definitely subscribe and check that out. Today I actually did it beforehand because I was trying. I skipped to doing a hard one. So I just want to make sure I have more time, especially since the contest is in about an hour of this recording. So definitely, if you're doing that, good luck as well, and wish me luck. Okay, so a transformation sequence of begin to end word is such that every adjacent is different by a single letter. Okay. Given I remember this one was. I don't know if this is the one, but there was one where I really hated, just because it is the definition of depending on the input case, right? Uh, Something like this one, but maybe I'm wrong. But yeah, maybe I'm thinking of someone else. But in any case, the idea will my first inclination is to do by first search. Do you have to? Oh, wait, is it? Maybe I'm thinking of a different one because I was thinking about the one where you have to do just one, but here you basically have to do all possible shortest transformations. That's not so bad. I mean, I'm still gonna do the shortest path, but but there's just there's just more bookkeeping, right? And bookkeeping, for those unfamiliar with the term, is just about tracking things in a good way so that you can, you know, use them later. Maybe I use it too generic or too generally, but yeah. Is it just me or today I have like a really huge forehead, or is that me normally? I don't even know anymore. Maybe it's the angle. Okay. Anyway, um, okay, yeah. So then let's get started doing it. So the way to handle this is also keeping in mind that this is similar to the way that I would think about it is if you do struggle with this one, definitely work on a more simple problem with the shortest path. Not just the shortest path with respect to getting the length of the shortest path, but also constructing the shortest path. So understanding that will be, I mean, I think maybe obvious just because that's, looking at the answer, but it'll help you definitely, like, if you think about progression, that would be the progression, right? Work on one where you just have to wait on any shortest path. Then now work on this one afterwards. I don't know that I have a problem for that off my head anyway, because everything is recorded live. So definitely check in the comments, or if you know one, then just leave it in the comments as well. And I appreciate you for helping. But that said, yeah. So the idea there is just yeah, okay. Breadth search to get the shortest path, and let's get started. I think there's some like weird things, but okay. So, how do I want to do it? So word list, let's just turn it into a set because so that it's like all of one lookup instead, or it's not all. It's all of one with respect to the input, but the input could be all of L for some length L, right? So, though apparently that's only 5 letters, so it's pretty good. Yeah. Okay, and then now we just do a breadth search. This is standard shortest path stuff that I'm constructing. So I'm not going to explain it too much, but definitely practice this. This is, I mean, this is a hard, but definitely shortest path comes up, especially nowadays, every on interviews and medium problems. So definitely check that out. So I have a and then what I also want is the previous, right? And this is just to keep track of the best thing from the previous one. And that's pretty much it, really. Yeah, I think the only thing that you have to be careful about is that I think we can bound this a little bit better as well. I mean, there are things you can do, but I'm just going to keep, a basic thing of a distance, just because. Why not? And then now we start at begin word. I think, is there some like weird thing where begin word has to be in there, or it doesn't have to be, or okay, it doesn't seem like it has to be. But does the last word have to be there? The last word has to be in there. Okay, fine. Okay. So then now we start by queuing begin word and oops. And I guess no, it's fine. You could define it any other way anyway, but we don't have to. So then, yeah, so while length queue, this is standard BFS breadth search stuff, and this is basically the ways you can do it. I guess we can take advantage of the fact that length is equal to 5. Otherwise, maybe you could take advantage of 500, because then you can do 500 times 500 times 5. What is that? I guess that's good too. Shouldn't matter either. Wait, so the two ways you can do it is by looking at every word to see, if this is close to this word. The other way of doing it is just by looking at this word and then try every 20, every alphabet, right? So 26 to the 5th is going to be 11 million. So let's do the word list brute force instead, right? And maybe we can. No, I was gonna say we could speed it up a little bit, but maybe we can speed it up a little bit. Let's just say, no, I guess, or we can and we will, but let's just say that this will handle it for. No, is that true? What am I doing? Yeah, okay. Let's just say not done is equal to set of word list or something like this, right? And then when we parse it, we remove this from, okay, so current word is equal to q.pop left, and yeah, and not done, we remove current, right? And then now we can parse all the other ones by, for word in not done, we go, and the reason why we want an extra one is just, at least the way that I was thinking through it, is because multiple words can lead to the same words even before you relax it. So yeah. Okay, so basically, and since this is breadth first search, there's there are a couple of things as well. So that if so basically if let me also write maybe current D is equal to D of current, right? So basically, if current D is greater than if current D plus 1 is less than D sub word, or if word is not in D, or this, if this is the case, then we set D of word is equal to current D plus 1, and then we do the previous of word, we append it with this current word, and then we append this word, right? And then we continue, I guess. And then the other case is if current D plus 1 is equal to D sub word, then we don't do any relaxing, but we do want to append this as the previous thing, right? So that's basically the idea here. All right, let's just print it out real quick. This is basically a progress check to see if I have any silly mistakes. Sometimes I'm more confident, sometimes I'm not, so yeah. Oh, because the initial word is in here. Yeah. Just in case, I guess. Okay, so does that look good? So it goes to hit, to hot, to dog. Nope, hot. Well, it thinks all of these is 1, so... Oh yeah, but that's because I'm being dumb, because I forgot the transformation thing, right? I have to do, the... Okay, so delta is equal to 0 for, I don't know, whatever, a, b in sip of word and current. If word is not equal to current, if a is not equal to b, we increment by delta. If delta is greater than 1, right, then we continue, right? Forgot about that part. Okay. So yeah, so this looks way better now, and that's what I mean by progress check, right? Because you don't want to write more code and then get confused where your bug is. Sometimes, and that just depends on your confidence, really. But yeah, this looks okay. So then now we go, okay, if d of n word, if n word is not in d, then that means that we haven't reached it, so then we could just return an empty array. Otherwise, then we have to construct this, right? So let's just say answer is equal to this, and then we return answer. And this is kind of similar to dynamic programming's path construction, or path reconstruction, sorry. So yeah, so then it is just we have a function, we have a go, we have a previous, and a current list. What do I want to say? Okay, so just the current word, and then a list. I don't know. I'm doing this way awkwardly, but yeah, and then we do a go on the n word, and then just like an empty array, and that should be fine. And then here we go, if current is equal to the begin word, then answer.append, just like a copy of this. Though we might have to reverse it. I think we do have to reverse it, so let's just do it this way, because I'm constructing it backwards. Otherwise, we look at the previous. So for, let's just say p in previous of current, we do list.append of p. We go p, and then we go list. Excuse my language, didn't mean it that way, but anyway, I think that should be good. Let's give it a spin. I don't know if I have to do it in each order. It seems like I forgot the last word. I guess I just have to do this, but I want to see if I have to return it in any order. Seems like maybe okay. I mean, I don't know if I just return the right thing, or just like some problems just require you to return it in a specific order, right? So, all right, that looks okay. Let's give it a submit, and let's see if we get a time limit exceeded like I did, wow, 3 years ago now. Oh, okay, cool. But today, it seems like that's okay. 866 day streak, yay. Yeah, a little bit slower than last time. What did I do last time? Okay, so I pre-calculated a lot of stuff first. But the same idea though. And I hash the words instead. And then I do 27 times. I don't know. I mean, I can't tell which one is faster. I guess sometimes it is, whatever. And then I just time limit exceeded. Why that time limit exceeded? I don't know. I guess it's fine. Anyway, I'll show you the beginning of the code again and the end. So what is the complexity here, right? Noting that when you have to output the word list, it is going to be at worst. Let's see, what is the worst case? I think the worst case is just that I don't know if I can construct a case. I guess you can, right? Because you can construct a case where maybe it's something like this. Maybe the worst case would be like AAA, AAB, ABA, ABB, BA, like all the all the things to BBB, and then all the things to CCC, dot, 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 and then it makes CCC the end. And then so now each path will have exponential. So then you end up with like, I don't know, like the, even like, I don't know, just very exponential, I guess that's the answer, right? So I think that's kind of the tricky part about this, is that you gotta, like it's, let's say we have 5 alphabets and 5 characters, right? You can imagine that, well, there are only 32 instances of between, you know, AAA to BBBBB, and another 32 to CCC, say, and then another 32 to here. So you can definitely like construct it that way, and each path will have, you know, 5 choices, and then 4 choices, and 3 choices. There's 5 factorial, and then that's 120. So that'll be 120 to the 5th, even if you have just 5 things, right? I don't know if my analysis is quite right, but in any case, it can be way expensive. I don't know if that's true. Maybe it's not. Maybe I made that up and to scare y'all, and my analysis is weak. We could play around with it though. Let's see. Right. Let's say we want to go to AAA to CCCCC, and then we do AAA. I guess we don't need to put that one because it's the beginning. And then I mean, this part may be a little bit slow just because I'm, you know, maybe I could write a code to do this, but yeah, alright, fine. Now, I mean, okay, fine. But the point, right, I guess we can just do this one, but I guess that still takes a long time to write out the binary numbers. Okay, fine. Even this one, it should, yeah. Even this one, you can see that, you know, and mostly just because I got lazy, to be honest, that it has 1, 2, 3, 4, 5, 6 answers, right? And I kind of didn't really use. I guess I used all of these, but yeah. And then you can imagine that if I added a new one, that'll be 8, or I don't know. My point is that it's very exponential, and you just have to rely on the inputs not being dumb, I think. Yeah, because you can construct a case that pretty much very quickly. Because yeah, if I had written this out, that'd be 120, right? I mean, we could play around with it. I have some time left, so maybe this would be a good easy anyway. So yeah, so for I in range of 32, we want to print, let's see, let's say bin of I, we replace 0 with A, and then we replace 1 with B, and let's see, that should work. But I am putting in too much stuff, but yeah, well. Oh, well, I mean, it doesn't work if you put it after the code, but oops, I guess I need at least one case to kick it off. Right, so something like this, except for we have to write path this, I suppose, but and also I have to do, and then I need to zpad it. I think it's Python zpad is a thing, right? I didn't z.fill. .zfill 5, right? Yeah, so then I could do this, and then now we can make it into one string. Oops. do the join, something like that maybe. Yeah, close enough, right? So I could do something like this. Huh? How did this happen? Okay, I guess I have to do one more, but it keeps on eating some parts of it. What's up the auto something. Yeah, okay. So this is a very basic thing, and then we can maybe see, print the length of answer just to kind of satisfy our curiosity. So this is, so okay. So I did do the math in front of you. So you can imagine that if we just do the same thing, but to CCC, to DDD, and this is just for 5 letters, 5 alphabet, right? And that only is 32 times 5, right? So 32 times 5 is 150. So actually 32 or 500 over 32 is what, like 12 or something? I don't know. You could, my math is terrible. I guess it's more like 15, 16. 16 is 48, right? So you have 16 of these, and each one of these takes 120, gives you 120 answer. So it's 120 to the 16, which is going to be too slow. So this is exponential, as I said. So yeah, that's pretty much the idea, really. I mean, I'm sure maybe you could construct even more ridiculous, combinatorial exponential explosion, but I'm just giving you one way to do it, right? So yeah, so this is very exponential. There's 120 answer, but each of these also contain, what's it, 5 times 6. So like there's also a lot of memory and stuff like this. But yeah, but that's my hand way of saying this is very exponential. So this really just depends on the problem not messing with you. Cool. That's pretty much all I have with this one. Let me know what you think. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye. I was just double checking to see whether I missed some other constraints that might have made it easier, but bye bye.